Hello everybody, welcome to Learn Teach YT channel. I hope you all are well. Yesterday, I guess we completed problems up to here, I guess, right? We completed up to here. Let's move on to the another kind of problems in number of zeros. Okay, there you go. Let's read the question first. Find the number of zeros in the following, that is, as you can see, 1 into 2 into 3 into 4 into up to 58. I know multiplying this will take a lot of time for us. As you can see, this is not the same format as the previous questions as I shown you here. So the technique is simple. All you need to do is just let's take the last number. Take the last number. You can divide it with 5. You understand, right? This is going to how many times? I guess somewhere about 11 times. Leave the remainder aside. We only need quotient here. So, yeah, 11. Again, take the 11 again. Divide it. What you need? Only quotient. Okay. Okay, we got, 11 plus 2. How much? 13. So, we will get 13 number of zeros. Because here, as you can see, in between 1, 2, 3, 4, we'll get 5. That means the numbers which are getting cancelled by 5 or will get 5 are nothing but 13. 13 times we get 5, That means the numbers which can get cancelled by 5. So we can get 13 5s. So 13 number of zeros we have. You ask me, why not considering the number of 2s, right? What I'm saying is, here, you can also do this 58 divided by 2, but it's going to drag too long because, for 58 divided by 2 means, you see how much you can take to lose 4, 14, sorry, what? Sorry, to lose 4, 29. 229 gives the value of this 58. So we need to do again like that. It's going to, it's get dragged on too long. As you can see, at the first division only, we got the value 29 means we get several values. By adding those values, we get so many number of 2s. Since so many number of 2s are guaranteed, let's say we got somewhere about 52 2s. Somewhere about. It's just my guess. If we got somewhere about 52 2s means 13 5s, 52 2s. That means 2 power 52. Let's take it like that. 5 power 13. How many pairs we form? Only 13 pairs will form. So, all we need to do is just get the number of 5s from the solution. That's the only answer. Since we got number 13, 13 is our answer, which is nothing but B. I hope you understand it. Let's move on to the next question. This is also the same. Find number of zeros in the following 1 into 2 into 3 into 4 up to 276. Let's do it. Sorry. What I'm doing here, let me erase it. I'm trying my best to, do the max calculations faster because I am very weak at it, but I'm trying my best. So please don't blame me. Okay, 5 5s, 25, 2 carries on, 5 5s again. 55. We got 55. 55 divided by 5, 5 11s, I guess. 11 divided by 5. 5 2s, 10, right? Somewhere about like that. 55, 65, 66 plus 2, 68. This is our answer. The number of 5s. The number of 5s we get. So, number of zeros is 68. That's it. That is our answer. Number of zeros, 68. Problem solved. That's how you do the question. You understand, right? Let's move on to the next question. Okay. Now this one seems somewhat tricky, but I will explain it quite easily. So there is no need for you all to worry about it. So just listen carefully. Find number of zeros in the 2400 factorial. Yeah, I know it's a big number. So factorial means what? 2400 factorial means we write it like 2,400 into 2,399 into so on up to 1, right? Why not just reverse it, man? Just reverse it. 1 into 2 into 3 into 4 up to, you can write it 2,400, right? You can either write like this, write like this, and you'll get the same answer, right? Both values are 2,400 factorial anyway. That's it. That's the easiest way. Let me take the eraser. I want to erase it because I want space to solve the problem, right? Let me get to, oh sorry, again. Okay, let me take the pen. 1 into 2 into 3 up to 2,400. Okay, what I'm going to do is that 2,400 divided by 5. By 4 is 20. And 4 carry onwards. 4 is 40. So 0 remains. 480. 480 divided by 5. 5 nines 45. 356. 96. 96 divided by 5. 5 ones. And 4 carry onwards. 5 set. 5 nines 45. 19. 19 divided by 5. By 3 is 15, right? 3 I get. Okay, 5 is 15. That's it. All you need to do is just add these values. Means 480. Let me add it manually so that, I get, okay, 18, 8, 4 plus 9, 13, 14, 15. Sorry, what's that? Sorry? Oh, sorry. We just need to add these, right? Okay. We got somewhere about 598, I guess. Okay. You understand, right? You understand how to do the problem, right? Okay, let's move on to the next question. Now, this is going to be quite tricky, but I promise you, I'll make it easy for you. So, here it is not starting from 1, right? That means all the problems that we do up till now start with 1 into 2 into 3 up to somewhere about 1868. But here the problem itself starting from 898 into 899 and so on up to 1868. So how do we solve this? I have an answer. So just follow me, you will understand what I'm doing. Okay? Just follow me. So what I'm going to do is that I'm going to calculate for this only. 1 into 2 into 3 up to 868 only. I'm going to calculate like this first, then we'll think about the rest. Okay? First, 1868 divided by 5. 8, 5 threes, 15. 3 carry forwards. 5 6, 30. 1 carry forwards. 5 threes. Wait, 5 threes, 15. We got 630. 363. 363 divided by 5. Okay, somewhere I think something wrong happened, I guess. Okay, let me erase it. Sorry. What? Yep. So not this one. Yep, this one. Sorry. Let me. I did some mistake, I guess. Yeah, somewhere around here. I'm sorry in case I'm very weak with these equations. So divided by 5. 5 3 is 15, right? A reminder we get 3, 36, 5 7 0, 35. 1 carry on forwards. So 18, right? 5. 18 means 5 is 15. So 373 divided by 5. So here 5 7 35 to carry forwards 23. 5 4 0. 74 divided by 5. 5 1s 5 2 24. 5 4 0 20 14. 14 divided by 5. 5 is 10. 5 is 10. So we get somewhere around this value. Let me do it. 3 plus 4, 7 plus 4, 11 plus 2, 13, 3, 7 plus 7, 14, 14 plus 1, 15, 15 plus 1, 16, 6. And the remaining value is 3 plus 1, 4, 463 is the value we got. Now what we are going to do is just the same way. However, we are only going to calculate up to 1 into 2 into 3 up to 897. So whatever the value we get at by solving this equation, we are going to remove it from the main value, so we'll get the original value. I hope you understand what I'm doing right here. Okay. 897 divided by 5. 5 ones and 3 carry on forwards. 5 sevens and 4 carry on forwards. 5 nines. 179. 179 divided by 5. 5 3 is 15. So 2 carry forwards. 5 is 35. 35 divided by 5 sevens. 7 divided 1. So just add it. 9 plus 5, 14 plus 7. 21, I guess. Yeah, 21 plus 22, 2. 7 plus 3, 10 plus 2. 1, 2. 1 plus 1, 2. Okay, we got this value triple 2. So what we are going to do is just 463 minus 222. Let's do it manually this also. For my convenience, because I am not that great at calculations. Okay, this is our answer, 241. Okay, I hope you understand how I did this sum. Okay, I hope you understand it. It's quite easy, but calculations are tough for me because I'm not that good at calculations. I'm openly, telling you all, and I'm confessing myself because I'm not good at math equations, but I'm trying my best to overcome it. So let's beat. Okay, now it is also same. 12, 1231 into 1231 factorial, right? This is 1231 into 1230 into, and moves on up to 1, right? We can also write it as 1 and 2 and 2, 3 up to so on, 1231. So all we need to do is 1231 divided by 5. 5 2s 2 remainder. So 5 4s are 20, 3 remainder, 3 carry on forwards, 5 6 36. 246. 246 divided by 5. 5 4s are 24, carry forwards. 5 9s are 49. 49 divided by 5. 5 9s are 9 divided by 5. 1 are. So 6 plus 9, 15 plus 9, 24 plus 1, 25. 1. 4 plus 4, 8, 9, 10. 305. 305 is our answer. We got the answer. That's how we do it. The number of zeros in the 1231 factorial. I hope you understand it. Let's move on to the next question. Oh, sorry. That wraps up the number of zeros, topic. The number of zeros topic is wrapped up. At the same time, I covered as much as questions, as many questions as possible for you all, so you can understand how to solve the problems. Okay, that wraps up the number of zeros topic and problem solving on it. Now let's move on to the remainder theorem. This one is going to be quite easy. Remainder theorem is nothing but all we need to do is just find the remainder. That's it. Just the same as before. Let's take this previous example only, 1231, right? 1231. And all we need to do is, let's just say, let's divide with 5 only. Why not? Quite easy, right? All we need to do is just find the remainder. For this, I'm going to do it like this only, because first I will do it like this. So after that, I will do it traditionally so that you can understand. I better, I prefer you to do this one. Try to learn this as much as possible. I am also trying my best. So, yeah. Okay, 5 2s, 10, 2 carry forwards, 5 4s, 20, 3 carry forwards, 5 6. So, here remainder is 1. Okay, you understand, right? In case if we were to do it like this, divided by 5, 5 2s, 10, 2 23, 5 4s, 20, 31, 5 6, 30. It is also gives the same answer, but it's quite quicker than this one. This is nothing but the remainder theorem. All you need to do is just find the remainder of the given problem or given problem. That's it. Let's look at the problem so you can understand how to do this. You know, you need to look at the different kinds of, different types of problems so that you can understand how to get reminder from those problems. Let me show you. This one, right? Let's find the, oh, sorry. Why my pen just more like that? Okay, here, we need to find the remainder of the following equation. So how do we find that? Let's write it down so that we have a good understanding about it. So what do we do now? What I'm going to teach is quite simple. First divide, that means all you need to do is just divide it like this. 59 by 6. First divide it like this, then 74 by 9. Divide like this first. Okay. 5 nines are 45, sorry, 6 nines are 54, I guess. 54, oh, sorry again, sorry. Wait, mistakes, so many mistakes. 6 nines are 54, so yeah, here, 54, right? How much we got remainder? Remainder we got 2, right? Since 2 is remainder, 54, right? 2 remains, so here 2 remainder. And this one is divided by 9, right? 9 eights, yes, 9 8 72. The remainder will be here also 2. So we got 2 reminders. You can either do it like this also, 6, and m is equal to 2. For your understanding and teaching, that's all. You can also do it like this. So we got reminders, both are 2. Both reminders as 2. All you need to do is just to get the final reminder, you need to multiply these 2. 2 into 2, we get 4. 4 is our remainder, 4 is our answer. That's it. That's how you do it. I hope you understand how I did the sum. Okay, let's do the second sum the same way as the first one, so you can understand. You get a better grip of it. Okay, in this order, I'm just going to do it like this. I don't want to. Okay, how many times? 3 8s 24. We get a remainder of 3, I guess. Yeah, 3 is our remainder. Okay, 8 to 16. Our remainder is equal to 1. So rem is equal to 2 into 1. We get the value of, 2 what? Not 3. 3 into 1. This is remainder, right? We get remainder 3 here. Remainder 1. 3 into 1. Oh, calculation 2, right? Okay. 3 into 1, 3. Our answer is 3. Just that simple. There is no need for you to overthink or anything. That's how you do the sums. Okay. Let's move on to the next question. Oh, that's quite a big number. Yeah, I know. Let me do it. I will try my best without doing any mistakes. So in case if I do any mistakes, please comment on the video so that I will try to correct it myself in the next class. Okay. 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 4 6 outside. 6 4 24, right? Okay. Now 6 6 36. The 1 is carry forward. 6 3 is 18, I guess. Again here the remainder is equal to 1. Okay. Now this one. 6 6 36 6 6 36. We get a remainder here 5 5 5. 6 9 is 54 1 13 6 2 is 12. Here also we got a remainder of 1. So remainder is equal to 1 into 1. We get 2. 2 is our answer. Yep. That's how we do it. Okay. Now let's move on to the next sum. Just as the same as before. Doing it same as before, just like previously. Okay. Let me draw this so that you can understand what I'm doing. Okay. For this one also. Okay. 9 8, I guess. 9 8 72. So our remainder will be somewhere about 3. Okay. Here also. 5 9s 45. Okay. 5. Okay. Yeah. 3 will be remainder. So here also remainder 3. So remainder is equal to 3 into 3. 9. But why don't I find the value of 9 in the actions? Either is it none of this? No, it is not none of this. But it is not the end of the problem because we need to continue it because that you need to remember the dividend divisor or dividend, I guess. Dividend, right? Is it dividend? Look at this one. That means if you are going to divide this one, remember this one must always be greater than remainder. 9 must always be remainder. Not even equal to also. It must be always be greater than the remainder must always be less than the 9. Remember. But here, remainder got equal to the whatever with whatever we are dividing. So this is not correct. So in this case, all we need to do is just divide it again. 9 divided by same this one only. Divide the 9 with the whatever the dividend which we use it to divide. Okay, 9 to 9, we get 1. It's not a remainder, it's a quotient. So our remainder we will get 0. But here we get remainder 0. Sorry, yeah, I just see I haven't changed this. Sorry for that. Answer is 0. Let's take it as D. Okay, 0 is our answer. Remainder 0 is our answer. I hope you understand. If we do the another sum, we'll understand how I did it. Let's take this sum. 85 into 75 divided by 8. Okay. How do you do it? 8 times, I guess. It ends 8. Remainder is equal to 5. So 8 nines, I guess. 8 nines are 72, and we get the remainder of 3. Here, your remainder as 5 into 3 is equal to 15, but the remainder must never greater than the dividend. Whatever the dividend which we use, it must never be greater. You understand? This one is wrong. 15 can never be, remainder can never be greater than the dividend. So this is wrong. So what we are going to do again, we are going to divide the 15 with the same dividend which we have here. 15 divided by 8 means 1 time. So we get a remainder of 7. Therefore, remainder is equal to 7. 7 is our final answer. I hope you understand it. Okay. That's how we do the remainder theorem sums. And we look even more sums in future. That means it's not future. In upcoming classes, we'll look through more types of these problems. What kind of problems? My English, I am getting more dumber and dumber, it seems, because my English, it's dropping. The level of my communication, the level of my speaking, it seems like it's dropping day by day. I don't know the reason why, but yeah. Thank you for watching the class. I hope you understand. But I think in this class, I somewhat, my English stooped so low that I felt like I am talking Butler English. I don't know the reason why, but I felt like I am talking in a Butler language. But yeah, just leave it at that. I hope, even though if I explained it in a Butler English manner, I hope you understand the sums. Okay, I hope you all understand how to do it. We successfully completed the number of zeros topic and the types of problems in it. We started Remainder Theorem. We have solved 3 sums. In upcoming class, I'm going to solve even more sums so that you can understand how to do those sums too. Okay, thank you for watching. Let's meet in next class. Load Beat signing off.